Good day. Today our topic is degeneracy in transportation model. Already we discussed about balanced transportation model and how can we solve the unbalanced transportation model. Now I can introduce degeneracy in transportation model. Myself, Dr. B. Suresh Kumar, Department of Mechanical Engineering. Here, for understanding the degeneracy principle in transportation model, I can utilize this problem. Find the optimal transportation cost of the following problem. There are 3 origins and 4 distribution centers are available. Supply and demand data also given in the table. From this, we can identify the total supply. The addition of supply value given in the table 10 plus 20 plus 30 plus 40 plus 50, I can get 150. And also I can identify the total demand that is provided by the problem 60 plus 60 plus 20 plus 10. From this I can get 150. So the total supply is equal to total demand is available with this problem. So this problem can called as balanced transportation model. In previous video, I discussed about how can we solve the transportation model with the Vogel's approximation method. So I can reproduce the table that is given by the problem. So the matrix is 5 rows and 4 columns. In that we can get total supply is equal to total demand. So that this problem is called as balanced transportation model. From this we can identify the penalty. So the large penalty is the first allocation we should made. So the 10. In previous video we discussed about how can we solve the transportation model with one method. So you can refer that. This presentation is mainly contributed with the explanation about degeneracy in transportation model. So you can refer the Vogel's approximation method with the previous video. So according to this problem, the total transportation cost can get rupees 60. Here what is degeneracy? Number of allotted cell by Vogel's approximation method. The formula m plus n minus 1. Here m is the total number of columns, rows, and n means total number of columns. So 5 plus 4 minus 1 is equal to 8. But the allotted cells, here you see 1, 2, 3, 4, 5, 6, 7. So 7 allotted cells are only available. So 7 does not is equal to 8. For the reason, we may introduce eta in least cost of an unallotted cell. This kind of an inequality is known as degeneracy in transportation model. In transportation problem, whenever the number of allocation by Vogel's approximation method, northwest corner method or least cost method is less than m plus n minus 1, then the problem is said to be degenerate 1. So to solve degeneracy, allocate an extremely small amount, it may be close to 0, which one or more empty cells of the transportation table, so that total number of occupied cell becomes m plus n minus 1 independent position. The small amount is denoted by eta, then solved by usual method, which is the degeneracy available into the problem. This is the procedure to solve the problem. Here you see I compare all the values that are available with the table, which means unallotted values 25, 7, 13, 12, 8, 4, 7, 9 and 14, 12, 5, 19. I compared all to each other. I can get 4 as the extremely small amount that is available with the given matrix, so that I can allot eta value in the unallotted cell as like this third row and first column. From this I can equate 8 is equal to 8 from 7 does not is equal to 8. So the 7 does not is equal to 8 is the degeneracy in transportation model. Now I can convert that degeneracy into normal transportation problem. So how can we solve? Yes, you see cost of unallotted cell, I can pick the values cost of allotted cell as like 10. Here this 4 also allotted cell. Now I can convert that is allotted cell 10, 4, 3 and then 9, 5, 7, 1, 0 are the allotted cell. Here I place 10, 4, 3, 9, 5, 7, 1, 0. In previous video we discussed about in optimality test how can we identify the u and v values, which means CRS is equal to ur plus vs, which is a formula used to identify the values of u and v. Likewise, I can identify the uv for considering the first cell, there is 10 available, so that I can introduce u1 is equal to 0 and v1 is equal to 10. So C11 is equal to u1 plus v1, so 0 plus 10 I can get 10. Likewise, I can move to third C31. Here also I can get 4. How? Yes, already v1 10 is available. For the reason I can introduce u3 as minus 6. 10 minus 6 I can get 4. And then the fifth row there is 3 available. 10 minus 7. From this I can get 3. Likewise, we can frame the other allotted cell with the u and v values. With respect to, we can get the uv values from the allotted cell cost. Okay, and then cost of unallotted cell. How can I get? Here you see unallotted cell in first row there is 25, 7. The second row there is 13, 12, 8, and then third row there is 7 and 9, and then fourth 14 available, and the finally in fifth row there is 12, 5, 19 available. So those are the unallotted cell cost. Here you see the same value represented here as like cost of unallotted cell. And then ui plus vj of unallotted cell I can identify from this u and v values that are identified from cost of allotted cell values. So now the unallotted cell, the second, okay, first row second column there is 1 1 because v2 is equal to 11 and u1 is equal to 0. So c21 I mean c12 here, c12 which is called c12 is equal to u1 plus v2. u1 is equal to 0 plus 11 I can get 11, so that I can represent here as 11. Similar to, I can get c13 as 5, c14 as 4. Similarly, I can perform all other cells with the identified u and v value from the cost of allotted cell. I can get the all other values. From this I can find ui plus vj of unallotted cell. Now cell evaluation I can perform with the identified cost of unallotted cell and ui plus vj of unallotted cell. How can I conduct the cell evaluation? I can subtract the cost of unallotted cell with the ui plus vj of unallotted cell. Here you see the first cell is cross mark I introduced because those are allotted cells, and then in first row second column there is 20 available. 20 minus 11 which are available with the unallotted cell. 20 minus 11 is equal to 9. Similar to same in first row third column 5 available and ui vj also 5. 5 minus 5 is equal to 0 and 7. In fourth column there is 7 and fourth column in vui vj unallotted cell is equal to 4. So 7 minus 4 is equal to 3. Likewise, I can perform all other elements that are available with the unallotted cells. Here you see all are positive values. In tabular column all are positive values. There is no negative value available, so that the optimal transportation cost from Vogel's approximation method is 670, which is the optimal value. So the optimal transportation cost is equal to 670. So degeneracy in transportation model means m plus n minus 1 is equal to should be within the number of allotted cell. Okay, this is the condition, which is m plus n minus 1 is equal to number of allotted cell. If the condition is not satisfied, means we can introduce eta value it into the unallotted cell as like this. So we can increase the allotted cell in the given problem matrix From this we can convert the problem between two satisfied condition. M plus n minus 1 is equal to number of allotted cell. We can solve the problem as usual method after that. Thank you all. Now you can understand what is meant by degeneracy in transportation model.